Today we're going to be looking at two different problems in solving molarity. So molarity is the concentration of the solute in the solvent. And it is moles per liter is how you divide it. But for this first problem here, we have 400 grams of sodium hydroxide in 5 liters of solution. So this does not give us the moles that we need. So this is going to be a two-part problem. So first we're going to have to calculate and convert grams into moles. So we have our given of 400 grams of sodium hydroxide. And we need to look at our periodic table to find out the molar mass to divide it by to get our moles. So for sodium, on our periodic table, if we zoom in here, so sodium we have is 22.99. So we have our sodium. There's one of those, hydroxide, so one oxygen as well. So we're going to add 16 to that 22.99. And lastly, one hydrogen at 1.01. So that comes out to an even 40 for the molar mass. So we look at the bottom numbers and we look to see how many there are. So there's one of each. So the molar mass for sodium hydroxide is going to be 40 grams. So what we do in this problem here, so it is times by 1 mole. Oops. And then the normal problems look like this, to where the mole is over our grams. Grams will cancel. So we're left with units of moles. So what you do is 400 times 1. So 400 times 1 is 400. Divide that by the 40 grams on bottom. So that's going to give us 10 moles of sodium hydroxide. We are then going to take this 10 moles and get our molarity. So 10 moles of sodium hydroxide, and it says 400 grams in 5 liters of solution. So we're going to then divide it by 5 liters of solution. So 10 divided by 5 is going to give us 2 moles per 1 liter. And that can be written as moles per liter, but you can do capital M for molarity of sodium hydroxide. So the concentration is 2 moles for every 1 liter for this problem here. So that's solving the first one. Let's look at a different one. So 107 grams of NH3 in 3.5 liters of solution. So this is the same boat. This gives us grams. If it gives us moles, we can kind of skip that first step. But we're given 107 grams of NH3. So we have to find the molar mass of NH3 on the table. There's not an NH3 that'll pop up on there, so you have to determine how many there are. So N, there's nothing that comes after it, so that means 1 nitrogen, and there are 3 hydrogen. So on our periodic table, hydrogen is 1.01, nitrogen is 14.01. So to find the mass of NH3, so you have 1 times 14.01 plus 3 times 1.01. And when you add those together, we get 17.04 grams. That's the molar mass of NH3. So we're going to plug that in down here and divide. So let's find our moles. So we have 107 divided by 17.04. So we're going to go to our calculator and type in 107 divided by 17.04. So 6.279. So with that, we can round up to 2 decimals, so 6.28. So we'll go back and put our number in here. So we have 6.28 moles of NH3. And these are the moles that we are going to use to divide by the liters given. So we have 3.5 liters is given, and molarity is moles divided by liters. So you have 6.28 divided by 3.5. So the first step is to divide. You get your answer. You'll use that for your moles. And the final step is to divide moles by liters because it's a fraction. Top divided by bottom. So we're going to clear this. And we have 6.28 divided by 3.5. So 1.7942, and we'll round to 2 decimals, so it's a 4, so we don't round up. So 1.79 is our concentration. So we have capital M for molarity, our concentration of NH3 in our solution. So we're going to look at the two concentrations now. So this is our final answer for 1.79 and 2. They're very close, but think which one would have a higher concentration. So 2 is larger than $2 is larger than $1.79. So 2 is a higher concentration than 1.79.